To solve this equation, we cannot solve an equation with sines and coses unless we can somehow split them up. So in this case, we really can't. It's a quadratic. We want to factor this, and we can't factor the sine and cos into separate parts. So what I'm going to do first is I'm going to convert this 1 minus sine squared into cos squared. So I end up with cos squared theta minus root 2 cos theta equals 0, and then I need to solve this. This is a quadratic equation, so I need to factor. So I end up with cos theta minus root 2 times cos theta. It's equal to 0. I can solve these independently of each other. So here I have cos theta is equal to 0. I need to solve that equation. Here I have cos theta equal to root 2. So in this case, cos theta cannot equal root 2. This is outside the domain. So I'm going to eliminate this one right away. And cos theta equaling 0, I can use my unit circle to solve this. So cosine is the x positioning. So I need to find the position of 0. It's going to be theta 1 is going to be at pi over 2. Theta 2 is equal to pi over 3. Sorry, 3 pi over 2. And those are that's 1 period worth of solutions. Now, in this case here, it says for all real numbers, so I have to determine the period of this function. So the period of this is 2 pi, and then I can find the repetitions based on that 2 pi. So plus n2 pi. Okay, so there's my generalized solution. This represents 1 period worth of solutions, and the n2 pi represents the repetitions of those solutions. In this example here, we have to recognize that this is actually a double angle identity. So the double angle identity, I'm going to separate that 2 out. So we end up with 2 sine 2x cos 2x. Okay, so this portion represents a double angle identity. And this allows me to put instead of having a separate sine and cos function, because we can't solve those separately because it's not factored, because of that plus 1, we can convert that all into one function. In fact, this works out to be sine of 4x. Now that I've converted that into one function, I can solve for the sine value. So I get sine of 4x equals negative 1 over 2. And then solving this, I can solve this trig ratio using my pictures. Sine is going to be negative 1 over 2. Let's draw a little bit better picture than that. Negative 1/2 sine is going to be in this position here, in quadrant 3 and 4. And these are going to represent special value angles of 30 degrees. Okay, so that the reference angle is 30 degrees, or pi over 6. So then we can say that theta 1 is equal to 7 pi over 6, and theta 2 is equal to 11 pi over 6. Now we solve for the angle. The angle is this 4x. But we actually need to still solve for x. So to solve for x, I'm going to divide by 4. So I end up with 7 pi over 24. And here I'm going to end up with 11 pi over 24. Now that represents 1 period worth of solutions. But because of this 4, that's a horizontal compression of 4, the period of this function ends up being 2 pi over 4, because a horizontal compression of 4. So my period is pi over 2. So then to get the repetitions of this, I'm going to go plus n pi over 2. Okay, so this is for all real numbers, so I need to get all the repetitions, and the period allows me to get the repetitions.